Hello, everyone, and welcome to another Directions Mag Geospatial webinar. Today, sponsored by our friends over at Census Tech. Stop by directionsmag.com for more webinars, daily news, and exclusive articles on geospatial topics. So we are excited to have Kyle Miller with us today, and he is going to give us some great tips and tricks for getting started with waivers and mapping with our drones. So welcome.
Thank you. Appreciate everybody that is joining the webinar today. Like the organizer said, we will be sharing a little bit about tips and tricks for not only just mapping, but a lot of the questions that we got beforehand that sent in from you guys are definitely around the waiver process, which it could be, and it is at times, a very complicated regulatory water to navigate. So we will be hitting a lot of those questions. We kind of baked in answers to a lot of those questions throughout the webinar. So we'll get rolling. It's only about a 12-slide webinar, but we'll be covering quite a bit. So and I guess it will be shared after the fact as well. So in this webinar, we're going to be going over two unique types of waivers. Obviously, there's a lot that can be applied for. There is everything from 107.51 covers 4 waiver classes on its own, right? 107.51 A, B, C, and D. We're going to constrain the conversation for this first waiver to just 107.51B, which covers high altitude, and we will also be covering sort of the catchy BVLOS waiver, so 107.31, and then tangentially 107.33, which is the visual observer waiver as well. So first thing we'll go into is high altitude waivers. These waivers are definitely underutilized. There's roughly 76 of them approved. I checked this morning. There's 76 total. If you kind of strip through and look at the sheer amount, a lot of them are duplicates. So to give you an idea, there's only about 30 unique individuals or entities leveraging the power of a high altitude waiver approval. That's not to say that they're impossible to get, but it does take a little bit of regulatory savvy, and it definitely takes risk mitigation being displayed throughout the application itself. So what does high altitude get you, especially in a mapping use case? Well, obviously your coverage is going to go up. You have a wider footprint. There's things to consider in terms of what sensor you're going to fly, a GSD that you need to maintain. Even at higher altitude, you might have to throw a different lens or a different camera entirely at the problem. Flying high and with a great sensor could be a very, very powerful combo. But again, it takes a little bit more than just being a great pilot in order to leverage what a high altitude waiver can get you. So that's a little bit of what we'll cover with this first slide of high altitude. So here are a couple of standard payload offerings that you kind of run some numbers with in our flight planner or any other flight planner, really, playing with altitude and having that output a ground sampling distance and a coverage per hour. So you see the box on the right, 1.3x ROI and a 2.2x ROI. Well, ROI is, what are we measuring it against? Well, we're measuring it against the 400-foot ceiling that our aircraft and a lot of other fixed wings, at least, that can carry a decent camera are flying at. We're flying at 400 feet typically. We're flying at 40 to 45 miles an hour typically. When we go up 30% with the R3 up to 600, well, our coverage goes up and so does our GSD. But our acreage per hour, if we don't need to maintain a 1 centimeter, 2 centimeter, whatever it is, GSD, let's leverage that higher altitude to get the job done quicker or to do more jobs per day. If you want to get really up there in the atmosphere, you can fly up to 1,000 feet, and there's approvals up to those heights before. I think it's pretty neat if you go on to the FAA Part 107 waivers issued. You can click that link. It's a link to the FAA's website, and you're able to filter and look at all the different approved entities for all these different waiver classes. So what we're talking about here in high altitude, in that search bar, 107.51B in parentheses, and you're able to look at all the entities that have garnered this permission before And in those applications, unlike BVLOS, on the high altitude waivers, you're able to look at not only the area that was approved, whether it be on the sectional or on the map, you're also able to look at the permissible altitude that was given the green light in that waiver itself. So we'll go into precedents a little bit towards the end of this seminar or webinar, but being able to see what people are getting approved kind of helps you plan for the future when it comes to some of these bigger jobs. Right here we have a model. This was taken at 400 feet. It was taken with a 42 megapixel camera, which would have been the A7R3 in our case. It was probably taken, if I had to guess, with a 55 millimeter lens. So roughly, several hundred acres per hour down to a 1 centimeter ground sampling distance. The flying altitude here, probably anywhere between 350 and 400. We typically set flight plans at 390 feet AGL. And we take off and land vertically. So with terrain following, we're maintaining that 390 plus or minus 10 feet throughout the entire flight plan. Tips and tricks for mapping with a system like ours is managing an overshoot and a lead-in when it comes to the project. So you look at it's a relatively square parcel. However, the aircraft, unlike a quad, although we take off and land vertically, we do fly at 45 miles an hour like a fixed-wing airplane. So we need to be able to, not if we're covering a square area of interest and collecting data over a polygon like that, we are going to overshoot that polygon, turn around, and get back on the grid. So tips and tricks, managing your overshoot and lead in. You can make the polygon for your data, where you're collecting the data, anything you want. The automatically generated waypoints automatically set all the camera triggers and distances. You're just tweaking things like altitude, tweaking things like overlap and side lap. For our plane, we typically set that at 70% on both. And then one big tip and trick that I wish I had at my disposal, or I knew about it, which I was trained on it, so I should have, but I completely forgot, is setting the flight into a crosswind. So we talk about the tolerance for winds on our aircraft being 20 miles an hour, gusts up to 25. Well, that's terrific. But what if we set it up into a pure tailwind? Now we have a 70 mile an hour ground speed. That's tough for the camera to keep up. So we typically set all of our flights for grids into a crosswind. So the next waiver we'll discuss, we've kind of hit high altitude. We will talk about BVLOS waivers. 107.31 and 107.33 is usually right on its heels. So 107.31 covers the line of sight regulation, get that waived. 107.33 covers the visual observer regulation, getting that waived as well. Common misconception with the .33 portion is that there's no visual observers at all in the entire loop. That is not really the case. It will be soon. But specifically for census, all of our waivers still leverage visual observers for now. But the visual observer's job is not to maintain eyes on the drone. The waivers, or the VO's job is to maintain eyes on potential ground risks. So prior to type certification, that VO's job is to maintain eyes on road crossings or anything like that, as well as monitoring airspace. So that is a temporary thing. It's something we're working towards as an industry and as a company. So, however, building that operational history now is what's ultimately going to unlock that potential. So, two different kinds of BVLOS waivers at a high level. You talk about geographically constrained waivers and non-geographically constrained waivers. Geographically constrained is exactly what it sounds like. It is area-based, kind of like this graphic shows. Normally, census constrains that to 20 linear miles or 20 square miles. Obviously, it is lower risk. There's a lot more approvals for geographically constrained areas. Census has 15 of them. We're working to start submitting these non-geographically constrained approvals because the volume of success and the volume of completed operations safely in a geographically constrained environment is starting to get pretty great. So geographically constrained, non-geographically constrained, this kind of puts it right where it starts to make some more sense. So non-geographically constrained is much more valuable. It is something that needs to be worked towards. It is process-based, so that system and process that Census has used to identify, analyze, and ultimately demonstrate a mitigation of risk is being used to display over a lot of different areas right now. Soaring Eagle Technologies is one example that's gone after multiple areas, one after another. That process to identify risk over these areas is ultimately going to be used to get the process approved and not the area. So will we still constrain it to an entire state? Probably. We will also be taking away things like we're not going to ask to fly over major airports, but the customer will go through the process used to identify and mitigate risk, but they won't have to submit that analysis anywhere. That's going to be a huge time saver. You go from about a 90-day process to fly BVLOS over a certain area to about a 3 to 4 day process, however long it takes that operating entity to conduct that analysis. If the area is really big, it might take closer to 4 days. If it's a tiny area, it might take more like 1 or 2. But that analysis won't have to go anywhere. You can operate anywhere that fits that risk bucket. So what does BVLOS even look like now? Well, line of sight with a system like ours is about a 1 mile radius. You can see and maintain attitude and orientation on our aircraft roughly at about a mile. We have some pilots here that think they can see it at 1.25 miles. I can personally determine attitude and orientation at 1 mile. So for easy math, we'll call it 1 mile. The radius that's being approved for BVLOS now is considered a low risk application attempt of a 3 mile radius with the aircraft operating beyond that a little bit more. So you have a VO at the 3 mile mark and the aircraft actually flies beyond that furthest VO. That radius is only getting greater, ultimately leading ourselves into point-to-point operations. So single launch point, you're talking about a 9x coverage per flight. Right now, when it comes to BVLOS mapping applications, you throw high altitude in that, it's another value add. And ultimately, BVLOS in 18 months, we're looking to be at a point-to-point, the full endurance of the aircraft at that point in time. So several things to consider when it comes to should we even bother with going down a BVLOS roadmap. It is a roadmap. It is definitely something that is a growing ROI over time. But one thing we always like to hit in some of these webinars is that there's ROI now, but it's only going to get bigger. Now, it only makes sense if it fits the business model. So starting the roadmap, well, where's the area of operation? It always makes sense to start with a geographically constrained BVLOS waiver. That makes a lot of sense because you're able to start building that operational history with a low risk of getting denied if the area fits the bill. If you're asking to fly BVLOS over Manhattan, you have a lower chance of success than flying BVLOS in a sparsely populated area in Class G airspace. One of them is way easier than the other. But over time, we will be starting to fly in more and more urban and semi-urban places. As the regulatory waters mature, as the technology industry-wide matures, ASTM certifications on parachutes become more common for aircraft in our class. Type certification is something that companies like ourselves are undergoing and will ultimately overcome. That's area of operations a big thing to consider. The frequency of the mission is the other. So if you're only going to fly this project once and you're never going to do it again and you never have a reason to fly BVLOS really ever again, it might not make sense to make the investment in the hardware, the regulatory process, starting that operational history. It might not make any sense. It might be a one-off. If it's a one-off, we would typically steer somebody away from the investment. But if it's a recurring theme, if you're a utility or a contractor to a utility that has a certain amount of mileage that has to be flown a certain amount of times, then you start to look at cutting into some of those operations and maintenance expenses with long-range assets like a BVLOS fixed-wing drone. It is cheaper to operate a fixed-wing drone than it is a manned rotorcraft. That is relatively common knowledge at this point, and it's something that I think that there's a proven roadmap to get to something that makes sense right away, even when you're investing in new technology. The box underneath frequency, we'll talk about precedence. So I hit on this a little bit in the beginning, but being able to look at what people are getting approved for right now is a great place to start. If nobody's ever gotten approved for an altitude that you want to get approved, it's, Census will write that waiver for that. We'll write a BVLOS waiver for something that's never been done, but it should all come from a place of managed expectations. So you have the ability to look at what's been approved. Go ahead and start looking at that, and that's a great place to start, is the altitude and the operational areas. And the last piece is the hardware. I will get to that question about the time that it takes to get a waiver approved. The hardware is the last piece of the puzzle. It is a very important piece. In those waiver applications for BVLOS specifically, they ask you for a complete system architecture breakdown, layers of redundancy, communications architecture, and the data to back up claims about your mitigation of risk. There's ways to outline that that need to be, the safety case needs to meet the ask. And if the hardware doesn't meet the ask, it's going to be a tough road. Trying to fly 50 miles point to point over Brooklyn with a Mavic 2, good luck. With aircraft that can meet a more robust operational request, you have a much better chance. So the average time that it takes to get a BVLOS waiver approved, we've had them approved anywhere between 30 and 90 days, 90 at the top end and 30 days at the low end. Depending on how big the area is, it might take 1 week to draft the waiver. It might take 3 weeks to draft the waiver. Depends on how complex the area is and just the sheer volume of mileage or square mileage. So linear mileage or square mileage. Operations and equipment considerations. So this is our little plug. This aircraft here has been approved for 15 different entities for BVLOS operations, largely in part to the onboard detect and avoid in the nose of that aircraft. So right in front of the plane, you see an optical sensor. That optical sensor is tied into a onboard AI computer as well in the avionics tray of the aircraft. If there's a manned aircraft flying in front of the plane or within 110 degrees and a mile out, that aircraft is going to autonomously avoid the manned aircraft. And then looking at the ground control side of the equation, you have layers of redundancy built into a mobile command center, whether it be a truck or a trailer or a van or anything like that. You have a communications mast to maintain radio link regardless of environment. You have a dual redundant ground control station, so if one burns out, it switches over to the other. And the whole command center, whether it be truck or trailer, is powered by a triple redundant power supply: generator, battery bank, and universal power supply in the ground control station computer box. So that entire piece of the puzzle is what ultimately garners approvals. And in 2021, we had a 100% success rate on applications that we submitted. And again, we don't submit these applications for Census. We submit them for folks like everybody on this webinar. You come to us with a project or a need or a customer that you're working with. We work together to draft a BVLOS roadmap that makes sense for not only the area, but your company, your business model, and how does that scale over time. All that stuff is put together pretty much on a one-to-one, customer-to-customer basis. So this will sort of conclude the webinar. In this regard, I see one other question on here that I didn't get to. The data coming off the system can be plugged into really anything. The video that I showed earlier was just done on Pix4D, and we've done everything from Bentley to Drone Deploy to Mapware to a lot of other different post-processing softwares. It just, the only consideration to make is we do fly for a while and we do fly a high megapixel camera. So as long as the processing solution can handle the data volume, you're in good shape. What payloads do the Census Tech fixed-wing drones accommodate, and how easily are they swappable? So our payloads are all field swappable. They all come in a universal payload box, backing it up to a picture of the plane. Underneath the fuselage in the center, every payload has its own box that slides in and out of the bottom of the fuselage. So they're all field swappable. However long it takes you to undo 4 thumb screws is how long it takes you to swap a payload. And we offer payloads everywhere from multispectral, hyperspectral, radiometric thermal, gimbal DOIR, 24 megapixel, 42 megapixel, 61 megapixel, and 100 megapixels. So as long as we can make a box for it, if it meets certain size, weight, and power requirements, we can integrate that payload into the plane. I think we've integrated a significant amount of payloads over the years because the aircraft's just a means to get a payload a certain place. And all of those payloads that I just mentioned, we all support multiple lens options for each of them. Last question, LiDAR is in the plans. We are working with LiDAR USA in that regard to integrate their Surveyor 32. It is integrated into our payload box. We are flight testing in the remainder of Q1, the first quarter of this year. So we look to have QA and QC reports available by the end of March.
So folks, he's generously sharing his information there, so make a note of that. Appreciate Kyle for sharing his expertise along with Adam's help with logistics. Have a great day. Tell a friend about Census Tech and Directions Magazine. Thanks, everybody.